Hi guys, Dr. Mandis here. Hey, today I want to wrap up our conversation about covalent bonding. Just talk about bond energy. Bond energy is just some of the intrinsic amount of energy that's in everything. In this case, we're talking about covalent bonds, the energy that's actually sticking the atoms together, the glue. Alrighty. Bond energy is basically talking about the making and breaking of bonds. So we're talking about the opposite of the exact same process. If you have so much energy that goes to gluing them together, it's going to be positive in one direction, negative in the other direction, but still the exact same amount of energy. Okay. So as far as energy goes, making is going to be exothermic, going to be a release of energy to make a bond. To take the electrons down into a lower energy state would be exothermic. And breaking the bond to undo that shared pair and break them back up again is going to be endothermic. More about that in just 1 minute. Okay, but the thing that you got to realize is it's always the exact same amount of energy. So whether it's going to be +5 or -5, but still the exact same value of energy. What's kind of cool about that is that means every bond is going to have different energy, but it's going to be well documented. A carbon-carbon bond is going to be worth so many joules of energy. A carbon-hydrogen bond is going to be worth so many joules of energy. And so all those bond energies are going to be found in tables or given to you in problems. And a molecular structure like strain in a molecule can change things a little bit, but for this and general chemistry, we're going to kind of ignore that and just treat all bond energy as constant, so you can just look them up. All right. As an example of why it's endo or exothermic, take a peek at what we got there. If you got A and B coming together to make AB, all right, in the forward direction, that electron pair has to be formed to make the bond. That's bond making. In the reverse direction, you're going to take the electron pair apart, and that's bond breaking. Okay, why is one exo or endo? I think you need to look at energy level diagrams to really get an idea of that. Okay, and to take a peek what we got there, we have electrons in atomic orbitals. Some people like the Venn diagram gig. Okay, well, for the electrons to come together and make a bond, all right, well, atomic orbitals become molecular orbitals. So we have molecular orbitals now in our diagram, in either diagram. Two atomic orbitals make two molecular orbitals. For general chemistry, that's about all you need to know. Okay? You already know that lower energy states are preferred. So for that bond to happen, the electrons here need to go down in energy, not up. If they're going to go down in energy, that's going to make a release of energy makes things exothermic. Already? And that's what we're going to see. So if you want to think about it for values, think of this electron being at 20 joules, the bond being at 5 joules. There's a difference there of 15. Okay, to go down 15 units of energy is going to be a release of 15 because you lost 15. A loss is a release. Okay, so that would be like -15 to make that bond. Okay, just for laughs and giggles of making up numbers. To take them back up, to go back up, you'd have to add that 15 back. It's the exact same value, just the direction of whether you're adding or losing. Okay. So that's kind of what we have there. The electrons coming together to make a bond goes to a lower energy state and therefore is exothermic. To break the bond takes them back up to a higher energy state. Already. Sometimes there's a misnomer on that. Sometimes people think breaking, you get energy out of bonds. So if you break it, you release energy, but that's not true. To break the bond, you have to take the electrons back up. To do it in food and stuff from ATP to ADP, and you break those high energy bonds, there's a pathway there. There's multiple steps. So what you're really looking at is the sum of a bunch of heat of reactions, not of just one bond. All right. Bond making takes electrons to a lower energy state. Bond breaking, higher energy states. Thing going to higher energy states is always endothermic. So let's take a peek at that here. In the first example, okay, you got two O atoms going to an O2 molecule. That's going to make a bond between them. In the second example, you have the methane being broken up, and that's going to be breaking bonds between them. Okay, so in the first example with the oxygens, you got bond making, so that's going to be exothermic. Delta H is going to be less than 0. And methane, down below the CH4, you got bond breaking, so it'd be endothermic. If these reactions were run in reverse, okay, then your signs of your delta H's would just flip. That's all. Okay. Exo becomes endo, endo becomes exo, that sort of thing. Alrighty. All right. The idea of the bond energy for the heats of reaction that I alluded to earlier, bond energies always add up to the total heat of reaction. Okay. So it's just an addition of the reactants plus the products. all right? But you have to understand, is the bond going to be broken or made? Well, bond break, so it's always bond breaking for the reactants because you're going to break up the reactants. Bond making for the products because you're going to add them together. Well, bond breaking is always endothermic. Bond making is always exothermic. So some people learn that that's, initial minus final or something like that. I think it's easier because deltas are usually finals minus initials always, and this is kind of backwards. A lot of teachers teach it that way. I like to just say, hey, do you know what's going on? Breaking versus making. Breaking the bond is endo, making the bond is exo. That's where that negative is coming from, but I think it's easier just to understand it. Okay. As an example, let's look at bond energies, calculate the heat of reaction for N2 plus hydrogen gas to make 2 ammonia already. If you look at that, with reactants, you're going to have a nitrogen and 3 hydrogens. And in the products, you got NH. Okay, so you have to break the bonds of the reactants and make the bonds of the products. All right, so let's take the reactants there, slide them down here, okay, and put the products over here, okay. Bond making is always negative, so we're going to have to incorporate a negative here. A lot of people like to slide the negative out there. You're welcome to do that, okay. But basically, just need to plug in the values, okay. So one more time, if we go backwards here, you have your breaking and your making, okay. Then you need to get the whole kit and caboodle together there, okay. These values here, all right, the values for the bond making and breaking, those would be in a table, okay? This value, that. You get them out of a table or usually supplied on your test or in the problem itself, okay? All right, that's just bond breaking and bond making for total bond energies. Hope you have a good time. I'm Dr. Mandis. I'll talk to you later.